Today, we're diving deep into the fascinating story of this celestial giant, unraveling its mysteries and exploring its profound impact on our understanding of the universe. Imagine a vast expanse of space, teeming with galaxies beyond count. Among them stands Andromeda, a colossal cosmic entity twice the size of our own Milky Way. But how did we come to know this distant behemoth? We will cover more of that in today's video. Before we jump in, click the subscribe and notification bell so you get notified when we release new content. Let's rewind the cosmic clock and trace the journey of discovery that led us to uncover the secrets of Andromeda. The universe harbors countless galaxies, many surpassing the Milky Way in size and brightness. Most are too distant to see without aid, except for the Andromeda Galaxy, which is visible to the naked eye. Twice the size of our Milky Way, Andromeda has unveiled crucial insights into the cosmos. Named after the Phoenician princess Andromeda, it's observable without magnification, mainly during autumn and winter in the northern hemisphere. Initially mistaken for a nebula, its true nature emerged with the telescope's invention in the 1600s. Andromeda's history dates back to 964 AD, but its identity became clear in the 17th and 18th centuries. William Herschel noted a reddish hue at its center, mistakenly estimating its distance to be 18,000 light-years. In 1845, William Parsons identified a spiral structure within Andromeda, labeling it a spiral nebula. This theory faced skepticism until Immanuel Kant proposed the idea of island universes, challenging the notion that the Milky Way comprised the entire cosmos. In 1917, Heber Curtis's observation of nova events within Andromeda shifted astronomical understanding. These events, though faint, revealed Andromeda as a distant galaxy, not just a nebula within the Milky Way. Curtis's findings reignited Kant's island universe hypothesis, proposing Andromeda to be around 500,000 light-years away, contrary to Harlow Shapley's belief that the Milky Way encompassed the entire universe. The climax of this debate occurred in the Great Debate of 1920, where Shapley and Curtis presented their arguments. Shapley argued for the Milky Way's dominance, while Curtis emphasized Andromeda's distinct characteristics, like its novae and dark spirals. The debate remained unresolved until 1924, when Edwin Hubble used the Hooker telescope to measure pulsating Cepheid variable stars in Andromeda, proving its distance to be over 1,000,000 light-years. This revelation expanded our understanding of the universe, revealing that spiral nebulae were individual galaxies situated tens of millions of light-years away. The recognition of Andromeda as a separate galaxy marked a significant milestone in cosmic comprehension. Andromeda's proximity offers a unique opportunity for observation, aiding in our understanding of spiral galaxies like the Milky Way. Today, advanced telescopes like Hubble provide detailed imagery and data on Andromeda, enriching our understanding of its celestial constituents. Andromeda, a barred spiral galaxy same to the Milky Way, comprises an outer spiral structure of dust and gas linked by a dense, bar-shaped concentration of stars at its core. Its structural similarities to our own galaxy suggest parallel evolutionary paths. Andromeda is believed to have formed approximately 10 billion years ago, and has since grown by assimilating other galaxies through collisions. The galaxy's tumultuous history is evident in its greatly elongated structure. The visible portion of Andromeda spans about 120,000 light-years in diameter, comparable to the Milky Way. Andromeda's stellar population dwarfs even the most generous estimates for the Milky Way, with over 1 trillion stars thought to reside within its bounds. Various methods have been employed to measure its distance from Earth, yielding a consensus of approximately 2.56 million light-years. The initial phase of this vast journey begins when we ascend beyond the plane of the Milky Way, reducing the obstruction of its starlight and revealing the galaxies beyond the local group. The immense scale of the universe becomes evident as we move past the outer stars of the Milky Way and its satellite galaxies, entering intergalactic space, which is nearly void in a gravity-dominated universe. For context, the air we breathe on Earth contains about 10 trillion atoms per cubic meter. Just above Earth's atmosphere in space, there are still a million trillion atoms per cubic meter. However, interstellar space between stars only holds around 1,000 atoms per cubic meter. In intergalactic space, this count plummets to just 10 atoms per cubic meter. However, intergalactic space isn't entirely devoid of matter. Only halfway into our cosmic journey do we enter the territory of the Andromeda Galaxy. Initially, we encounter its vast galactic atmosphere rather than its star-filled regions. Similar to the Milky Way, Andromeda is surrounded by a diffuse halo of plasma, likely expelled by past collisions, with a staggering radius of 1.3 million light-years. Within this atmosphere, Andromeda harbors satellite galaxies, each offering insights into its tumultuous history. Messier 32, a diminutive dwarf elliptical galaxy, presents as a fuzzy, golden blur within Andromeda's vicinity. Despite its modest dimensions, around 6,500 light-years wide, it harbors a supermassive black hole exceeding 1 million solar masses, hinting at a potentially grander past as a spiral or lenticular galaxy. Messier 110, another elliptical satellite of Andromeda, surpasses M32 in size at roughly 17,000 light-years across. Like its smaller counterpart, M110 likely underwent interactions with Andromeda, shaping its current state. In Andromeda's halo, faint dusty lanes rich in metals reveal remnants of stars from a satellite galaxy's encounter. Imagining within M110, Andromeda's disk dominates, evoking reflections on historical and societal implications. Moving to Messier 33, the Triangulum galaxy, the third largest in the local group, spans 60,000 light-years. Its status as Andromeda's satellite or an independent galaxy remains uncertain, with evidence of past interactions. Further out, Andromeda's extended disk shows signs of past collisions and gravitational influence from galaxies like Triangulum. Recent observations hint at its transformation into a ring galaxy, with NGC 206 and Male 2 indicating dynamic evolution. Andromeda's stellar population resembles the Milky Way's, with old and young clusters, nebulae, black holes, and potentially habitable planets. Unfortunately, studying its planetary systems remains challenging due to the distance. In 1999, scientists detected a possible exoplanet in Andromeda through microlensing, suggesting billions of planets there. Andromeda's black holes hint at its history of mergers. Its largest black hole, over 100 million times the Sun's mass, influences its galactic tide. Andromeda's collision course with the Milky Way, evident in its bluish tinge and speeds of 110 kilometers per second, will merge them into a single galaxy, shaping our cosmic future. Over the course of the next 2 billion years, Andromeda will steadily increase in size in the night sky, gradually surpassing the moon and all other celestial objects in brightness and magnitude. Within 3 billion years, it will dominate a significant portion of our field of view, obstructing our view of the universe beyond with its light and gas emission. In approximately 4 billion years, Andromeda and our own Milky Way will collide, resulting in a chaotic merger that will reshape their structures and scatter their gases. Despite the immense number of stars involved, actual collisions between them are statistically unlikely due to the vast distances between individual stars. However, close encounters will disrupt the orbits of planets within their respective systems. The fate of our solar system hinges on its position during and after the merger. Numerous simulations have been conducted to predict its trajectory, but there is no definitive consensus. It may be flung outward towards Andromeda or ejected into intergalactic space, or it may be drawn inward towards the center of the new galaxy, potentially leading to its destruction. Following the merger, the two supermassive black holes at the centers of Andromeda and the Milky Way will eventually merge, emitting gravitational waves that will ripple across space for billions of light years. This process will culminate in the formation of a new supermassive black hole at the heart of the merged galaxy. Once the merger is complete, a new supergiant elliptical galaxy, tentatively named Milkomeda, will emerge. While galaxy collisions like this are common and play a crucial role in galaxy evolution, they also have limits. The resulting elliptical galaxy will gradually absorb its satellite galaxies over billions of years, including the Triangulum galaxy. Over the span of more than 150 billion years, Milkomeda will consume the last remnants of its surrounding galaxies. However, its star-forming capabilities will diminish as star-forming gases are depleted, resulting in a decline in the stellar population. Eventually, the galaxy will stagnate, with its stars cooling and fading until they are no longer luminous. Ultimately, the story of Andromeda, the Milky Way, and their merged form will come to an end as the last stars fade away, leaving behind dark, inert remnants of what once was. Humanity emerged in the midst of an epic cosmic saga, well after its tumultuous beginning and long before its inevitable conclusion. The narrative of Andromeda is closely linked with that of the Milky Way, far beyond what early astronomers like Al-Sufi, Curtis, Shapley, and Hubble could have fathomed. It's been just a century since we recognized M31 as a separate galaxy. Consider the vast expanse of knowledge our future generations will unearth in the coming century. Thanks for sticking around till the end of this mind-blowing journey through the cosmos. If you found this video as mind-expanding as we did, don't forget to smash that like button and hit subscribe for more fascinating content about the universe and beyond. And remember, keep looking up at the stars because who knows what incredible discoveries await us out there. See you next time